Factorization. The incrimination, subjugation, and subsequent imprisonment of numbers, whether they like it or not. Alternatively, expansion means the very opposite, removing them from their very cages. And well, since we are into some friendly neighborhood peacekeeping and favor freedom, we might as well begin with expansion. Let's look at our two numbers within the brackets, miserably locked away. For simplicity's sake, before we even begin, we can represent this same example without the multiplication symbol, and it will mean just the same thing. The 5 outside of the brackets means that everything inside of the brackets must be multiplied by 5. Hence, we get 5 times 2 plus 5 times 3, which will equate to 15 plus 10, and so add up to 25. Now, you might say, "You stupid! Why didn't you just add the numbers inside of the brackets first, adding up to 5, and then just multiply 5 by 5, getting 25 in the process? This will make the whole operation much more simple." But don't get angry, my dear over-evolved monkey. This is where the use of expansion actually comes in. Let's say that one of our numbers is an unknown, represented with an x. Oh, actually, it's just a number, which we don't know. We can represent it with anything. Wait a second. Even better. What that means now is that we cannot preemptively add the numbers in the brackets, because, well, we don't know what we're adding to our known number, in this case 2. Therefore, now we have no choice but to expand it, as we did before. Thus, we get 5 times Shrek plus 5 times 2, and we get 5 Shreks plus 10, so 5 times of an unknown number plus 10. If you look at this next example, it may seem a little sketchy, but the exact same operation happens. Both numbers inside the brackets will be multiplied by the number outside of the brackets, so x times x and 2 times x. Except, since our unknown would be multiplied by itself, it will be squared, hence we get x squared over to the power of 2 plus 2x. Aha, well, you don't even need to ask, as I already know what are you wondering, and it is, well, what happens when the number within the brackets is multiplied by another set of numbers within brackets? Actually, in a sense, the exact same thing happens. You have to make sure that each number from inside one of the brackets is multiplied by each number within the other set of brackets. Well, as I'm about to show you, just a reminder, when there is no sign, it does represent a multiplication symbol between the two brackets. So let's begin. With x multiplied by x equals x to the power of 2, or x squared. Then x multiplied by 3, we get 3x. If we then go on to multiply 2 by x, which will give us 2x. And finally, 2 times 3, which would give us 6. And with that, we have multiplied each term from one of the brackets by each term from the other brackets. Hence, we have gotten 4 terms. To check that we have done this right, the number of terms that we have gotten should equal to the number of terms in one bracket multiplied by the number of terms in the other bracket. We have 2 numbers in one and then 2 in the other, so 2 by 2 equals 4. Nevertheless, all that is left now is to add the like terms together. And with that, we have finished the topic of basic expansion. But before we go on to pet that turkey, I will have to present you with expansion's evil brother or sister. I don't know. Yo, who the fuck made this script up? Well, as I said, factorization is the exact opposite of expansion, whereby we get the numbers and put them into the brackets. But before we dive into factorization in itself, let's look at the useful tool by which we will lock away our numbers behind the bars.
Hello!
The highest common factor, or HCF for short, is the highest common value by which a set of numbers can be divided. For example, let our set be made of the two numbers, 12 and 8, and let's see every number by which they can be divided. For 12, that will be 1, 2, 3, 4, 6, and 12, whereas for 8, we will have 1, 2, 4, and 8. As we can see, they have more than one common factor, but 4 is the common factor which is the highest out of all. Therefore, 12 and 8 share the highest common factor of 4. And now that we are armed with that
knowledge,
let's see, is it needed? If we go into our first example, 4x plus 8, in order to factorize it, we will need to take our highest common factor and divide each term by it. We shall then take our divided number and log them up in the brackets, while leaving the HCF outside. Hence, for 4 and 8, our HCF would be 4. So when we divide each of the terms by 4, we get 1x plus 2. Yet again, another unwritten rule of math. When we have one lots of an unknown number, we can remove the 1 and leave just the x. By factorizing our term, we have now simplified it, but it is very important to pay attention that full simplification occurs when each term inside the brackets is at the lowest possible value, as it will be divided by the highest common factor. If we have a common factor like 2, for example, the expression will not be fully factorized and hence will also not be fully simplified.
Wait a minute!
What if we have numbers which do not have a common factor, however, like 2x and 3? Well, first, even these numbers do have a common factor, and that will be 1. They don't have another common factor, therefore 1 would also be their highest common factor. This means that this expression is not further factorizable and it is fully simplified. So what if you have a situation like this, where both terms are lying around with an x, one of them being squared? Well, first, before even going to the highest common factor, we can see that they are both multiplied by x, where 4x squared means 4 times x, and 12x means 12 times x, and hence both numbers have a common factor of x, and we can take that out of the brackets already. Then, however, we can go on to spot our HCFs. In this case, that will be 4, and so taking it out as well, and dividing both terms by 4x, and so we can place x and 3 inside of the brackets. We ignore any 1s from the multiplications, as anything divided by 1 or multiplied will just remain the same. If you're still with me and your brain hasn't shut off yet, well, that's good. Alternatively, go and grab yourself
sexy banana,
and that might help bring some potassium to your rather underdeveloped brain cells. If we look at this last beautiful gem, not that one, we now have 3 terms. If you remember our last expansion example, you will already know how will this look when factorized. Let's break this down. First, look at our x squared. We can see that this is a term purely created by an x multiplied by another x. Shifting towards the end and looking at the number 2, it is a number just multiplied by another number. There are no x's in it, so let's call 2 the product of 2 unknown numbers, a and b. And lastly, when we move to the middle term, we can see that it includes both an x and a number, 3 in this case. This would mean that it is an x multiplied by a number. And if you remember, it will be 2 different cases where x is multiplied by another number and then those 2 cases are added together. We know that one of these numbers in each case will be x, but we don't know the numbers by which the x is multiplied by. Well, these numbers are actually the same numbers which were multiplied to make 2, so the same a and b. Now, however, they need to add together to make 3. So how do we figure out a and b? Well, I just said it. A and b are 2 numbers which will multiply together and make 2, but will add up to make 3. Okay, I'll give you 10 seconds to figure it out. 10, 9, 1. Alright, time's up. So those 2 numbers are 1 and 2. It therefore means that we can take those numbers and put them together in the brackets with the x's. To check if we have factorized it correctly, we can simply expand it back out. X times x is x squared, x times 2 is 2x, 1 times x is x, 1 times 2 is 2. After adding up the like terms together, we get our original answer again. Well, you can finally regain some of your lost self-esteem, as you have managed to reach the end of this math guide. But this is just a small piece of the infinite power that this glorious
knowledge
can provide you. Remain smart, remain curious, and keep on learning.